Wialon is a GPS tracking and fleet management platform developed by Gurtam. It is used for real-time vehicle tracking, fleet monitoring, logistics management, and asset tracking across various industries. The development kit is explained below. These are the test deliverables and accessories. Now, let's walk through the setup process for the Rugged Telematics device, which will be used to test Wialon cloud-based GPS tracking and fleet management platform. First, let's take a look at the interfaces on the Rugged Telematics device. These include antenna ports for cellular, SMA, GNSS, and Wi-Fi. Next, we have the 35-pin connector, which is used to connect the standard harness cable. On the other side of the harness, you'll find interfaces for the OBD connector, HS, CAN2 CAN FD, Debug UART, and others. Power boards act as an interface between the deliverable and the J1939 simulator, allowing for continuous sending of J1939 data. For testing, we'll connect the OBD connector and HS, CAN2 CAN FD interfaces with J1939 simulator using the power boards, as shown. The OBD connector will receive CAN0 data, while the HS, CAN2 CAN FD will handle CAN1 data. Next, we have the antenna, which will provide network connectivity and allow us to retrieve GPS data. The antenna has 3 ports, which we will screw into the corresponding interfaces on the board. Now, connect the Debug UART interface to the serial debug port, which in turn connects to the serial board. Use a USB cable to link the serial board to the debug terminal. Finally, power on the J1939 simulator and the connected deliverables, as shown in the setup. Connect the Rugged Telematics device to your computer using a debug USB cable. Open Minicom, Linux, or Terraterm, Windows, to establish a serial connection. Boot the Rugged Telematics device and run the Wialon application. Here, we are sending a read data by identifier diagnostic command with 0xF190 as the subfunction to the device from the Wialon server. The subfunction 0xF190 specifically requests the vehicle identification number, VIN. The device will process this diagnostic command and respond with the VIN. Following this, we're sending the next diagnostic command, C, with the subfunction set as report DTC by status mask and 1234 as the status mask, from the Wialon server to the device. The device will then check if any diagnostic trouble codes are recorded corresponding to this status mask. If any are found, it will send back the DTC to the Wialon server, where we can view it in the message pop-up box. Next, we're transmitting a routine control command to the device. This command executes a specified routine on the board. If the routine executes successfully, the device will send a routine success message to the Wialon server. You can observe that the routine has been successfully executed on the device because the Wialon message pop-up box displays the routine_success message. Finally, we're issuing a reset_device command to the device. This command initiates a reboot of the device and responds with a device reset_success command. You'll notice this confirmation in the Wialon message pop-up box. Here we are verifying the remote configuration with the Wialon server. Using the Wialon server, we can configure the device. Wait a few seconds to establish the connection with the Wialon server. Once the connection is ready, we can start configuring our device from the Wialon server. First, I will disable the CAN data. After disabling, the CAN data will no longer be sent to the Wialon server. This can be confirmed by checking the message table, where the CAN data will not be present. Then, I will re-enable the CAN data, and you will be able to see the CAN data being received in the message table again. Now, I am disabling the extended data. Extended data is a type of message packet provided by the Wialon server. You can observe that extended data is no longer showing in the message table. You can now observe on the terminal that extended data transmission is not occurring. You can observe in the Wialon message table that the extended data is not available. Now, I am enabling the extended data. After enabling extended data, the device resume is sending extended data, and it becomes visible in the message table again. You can observe in the Wialon message table that the extended data is available now. Next, I am disabling the short data. Short data is another type of message packet provided by the Wialon server. You can observe that short data is no longer showing in the message table. You can now observe on the terminal that short data transmission is not occurring. You can now observe on the terminal that short data transmission is not occurring. Now, I am enabling the short data. After enabling short data, the device resumes sending short data, and it becomes visible in the message table again. You can now observe on the terminal that short data transmission has restarted. You can observe in the Wialon message table that the short data is available now. Here, we are sending a photo updation command from the Wialon server. You can check the Wialon server log to confirm if the command was successfully sent to the device. If successful, a green message indicating photo_updation delivered to unit iWave system 1 will be displayed in the Wialon log. You can observe the photo update starting on the device terminal. Wait 5 to 10 minutes for the update to complete. After the photo update is complete, the device will automatically reboot. After the reboot, the Wialon application will start running again. At this point, the Wialon application will check the photo update status and send a success or failure message to the Wialon server. You can observe photo_updatation_success on Wialon message pop-up box. Now we are going to check the Wialon photo update failure scenario. Run the Wialon application and wait a few seconds for the network connection to establish. Once the connection is ready, execute the photo updation command from the Wialon server. You can check the Wialon server log to confirm if the command was successfully sent to the device. If successful, a green message indicating photo_updation delivered to unit iWave system 1 will be displayed in the Wialon log. You can observe the photo update error on the device terminal. After the photo update is filed, the device will automatically reboot. After the reboot, the Wialon application will start running again. At this point, the Wialon application will check the photo update status and send a success or failure message to the Wialon server. You can observe photo_updatation_failed on Wialon message pop-up box.